All right, hello. So we're going to continue digestion. So now we're moving from the mouth to the esophagus and into the stomach. All right, so the stomach is our next point of reference in our pathway as we're moving through digestion. And so what's going on in the stomach? Well, number one, it's a storage place. So your food goes down into your stomach, and that's where it's held until it's ready to move through the small intestine for the rest of the digestive process, then on to the large intestine, and then out of the body. So storage is a big function of the stomach, and you know that because if you eat a meal and all of a sudden you feel full, that's your stomach feeling stretched out. So it's storing it, and then it's going to start to move it on into the small intestine. But before it can move that food into the small intestine, it's got to start breaking it down. And so one of the things the stomach does is it churns. And you can sometimes feel your stomach churning and kind of breaking that food down like a big mixer. But it's also going to start the digestive process. Remember that dissolving? It's going to start to break down proteins. We call that denaturation of proteins using hydrochloric acid. Another word you might want to use instead of denature is like unravel. So think about proteins, remember they had all those twisty kind of shapes. If you start breaking those bonds, they just start to unravel. So then you can break them down into smaller pieces. Some of the proteins or enzymes that we use to, well, let me go back. When you break down proteins, you start by denaturing them with hydrochloric acid, kind of unraveling them. And then to start breaking them down into smaller and smaller pieces, you use enzymes. And one of those enzymes is pepsin. And in infants, they have an enzyme called renin. That's not the same thing as the renin-angiotensin system. This is an enzyme that helps break down milk. All right, so they have that to break down the milk because infants just use milk for their source of nutrients for the first couple of months of their life. So what these enzymes do is they chop those proteins down into smaller and smaller short chains of amino acids called polypeptides. And then eventually we'll be able to break those down into amino acids. So this is just that first step in breaking down the big proteins going on in the stomach using acids and enzymes. Now, as it's storing, it's also making something called chyme. And so when you put food into the stomach and it starts to be digested and liquefied, that liquefied food is called chyme. And chyme is what's going to be propelled into the small intestine for digestion to continue. So you eat the food, it's added to digestive juices and kind of churned and broken down, forming this kind of liquefied food that we call chyme that then we can send further down the digestive tract. Now, very little is absorbed in the stomach, but there are two exceptions, and maybe more, but these are the two you have to know, and that's alcohol and aspirin. So aspirin can quickly get into your system if you have a headache, and so can alcohol. That's why if you drink on an empty stomach and it seems like it just went straight to your head, it's because it is absorbed readily through the stomach. Okay? So we'll do some more anatomy on the anatomy lab video, but in general, your esophagus is going to come in, and the stomach is kind of this almost a bean-shaped organ, a little bit. It kind of looks like almost looks like a kidney a little bit. And so you've got several different main portions. The top, which is going to be closest to your diaphragm, this kind of rounded area, is called the fundus. That word may seem familiar to you. Remember we talked about the uterus? The uterus has a fundus, just that high point. It has two curves. So there's the kind of the small curve called the lesser curve, and then this large curve called the greater curve. The area that's closest to the small intestine is called the pyloric area. So this whole area is kind of the pylorus in here. So you have your pyloric sphincter right here. So this is where the chyme is going to leave the stomach and go into the small intestine. So this kind of bottom portion is the pyloric end. The top side near the fundus where the esophagus comes in, this is called the cardia because it's closest to the heart. So you have your cardiac sphincter there, which prevents regurgitation. One thing that is kind of interesting about the esophagus and the stomach, because the esophagus passes through the diaphragm, as you breathe, as you inhale and exhale, and the diaphragm kind of balloons up and flattens out, when you exhale, that the sphincter kind of relaxes, so food can pass through your esophagus. It kind of passes through on the breath, because as your esophagus kind of relaxes and contracts, that opens up that sphincter and allows stuff to move through it. So that's just kind of one interesting thing about the way the esophagus and the stomach work, is it depends on your breathing, allowing that sphincter to open and close. Not testable, just kind of interesting. Another thing about the stomach, because it is churning and mixing, it does have musculature running in several different directions, so it can do that mechanical breakdown. It also has kind of a folded inner lining called the rugae. And so when the stomach is full, those rugae are all kind of flattened out and taut. And when it's empty, it collapses in on itself. So it really allows to increase the space inside the stomach so it can hold more food, would be one idea about the rugae. And it's lined with mucosa. So this is where the protective barrier that prevents the hydrochloric acid that's in your stomach from digesting your own stomach. That rugae has a mucosal layer for protection. So that mucosa comes from simple columnar epithelia, which maybe you remember back from your earlier anatomies, and it makes an alkaline mucus. So hydrochloric acid needs to be counteracted by a base, so it makes an alkaline mucus that's full of bicarbonate that helps to neutralize the acids and prevent your stomach from digesting itself. Okay. You also have along the stomach lining, you have these pits called gastric pits, and they make the gastric juice. And gastric juice is primarily hydrochloric acid. It has some sodium chloride and potassium chloride, but primarily hydrochloric acid, and its job again is to start that breakdown or unraveling of the proteins. So if you look at the stomach and you do a kind of a microscopic view, you'll see you have these pits here, and so you have gastric glands. So the juice is going to be made in these areas here and pass out of the gastric pit onto the surface of the stomach. Okay, there's different types of cells. You have some mucus cells, you have parietal cells which make hydrochloric acid, and you have chief cells which make pepsin. So you have the acid cells, which again they help to denature the protein, unravel them, and then pepsin is the enzyme that starts to break down protein. Okay, so two different cells help make the stuff that's going to break down protein in your stomach: parietal cells and chief cells. Okay, so remember what they are and what they make and what that's for. Another thing about the gastric pits, you have another type of cell called an enterendocrine cell, and these are going to make some hormones that we'll talk about in a little bit. You got your chief cells for pepsin and your parietal cells for hydrochloric acid. And it's really cool that these two are found together, form follows function. And so when they make this gastric juice, there's a protein, an enzyme called pepsinogen that's in its inactive form, and the way it's activated is in the presence of hydrochloric acid. So these cells release pepsinogen, these cells release hydrochloric acid. Hydrochloric acid converts pepsinogen into pepsin, and pepsin is the thing that breaks down protein. Okay, so they're nice, they're right there next to each other, they can be released and help you break down your proteins. I don't know if this is, I've heard this and I keep saying I'm going to go back and read for sure and double check, but I think the reason Pepsi is called Pepsi is because it was first sold as a digestive aid. So if you had an upset stomach, you could drink Pepsi, and so I think somehow Pepsin and Pepsi are related as some kind of digestive aid. Somebody needs to look that up for me and send me something on the discussion board. Let me know about that. But I've read that somewhere, but I don't quite remember. But it seemed like Pepsi and Pepsin have something to do with each other, and the original reason they had Pepsi was to help calm your stomach down. All right, so again, this gastric juice is made up of hydrochloric acid from the parietal cells, which again is an acid which helps break down the protein, activates the pepsin, and also it helps break down plant cell walls. So if you think of cells, animal cells don't have a cell wall, they have a cell membrane. But plant cells have a cell wall that's tough, and so that needs to be broken down too so we can get to the good stuff inside the plant that we're eating. So the hydrochloric acid will help us break down those cell walls so that you can get to the nutrients inside the cell. And also, it's a way to kill bacteria. So this hopefully will keep the bad stuff from getting into your digestive system. So if you eat something that's contaminated, hopefully the HCl is enough to kill it. Not always. There's another thing that's released at this point called intrinsic factor, and it plays a role in absorption of vitamin B12 in the small intestine. So in order for you to get B12 into your bloodstream out of the small intestine, you have to have intrinsic factor. And so that can be a problem with people who have a lot of stomach issues. They may not have intrinsic factor, and they may have trouble absorbing vitamin B12. You see that a lot in older people, and so they'll get a vitamin B12 shot because they're no longer able to absorb that B12 because they lack intrinsic factor. The chief cells, they make pepsinogen. Remember, it's the inactive enzyme that's activated by hydrochloric acid. And this is one of those positive feedback mechanisms. So the more pepsinogen, the more hydrochloric acid, the more pepsin, the more conversion you get. So it just kind of feeds back on itself in a positive feedback way versus negative feedback, which is what we typically talk about most of the time. The chief cells also start to make some lipases, and this begins the digestion of fats. So about 15% of the fats are going to start to be digested in the stomach and by these enzymes that are being released. The hormone that's released, one of them is gastrin, and it's a hormone that stimulates the secretion of those gastric juices, including hydrochloric acid, the mucus, and the pepsinogen. So you do have a hormone that acts locally, so you would kind of call that a paracrine. Okay, so these you do have some hormonal control over the release of hydrochloric acid, pepsinogen, and mucin. Remember, the stomach has got a really thick mucosal barrier, otherwise it would digest itself. It's a bicarbonate-rich mucus. There's also tight junctions between the epithelial cell lining of the stomach to prevent anything from oozing through or leaking through and causing damage to the stomach. Obviously, you know, you can eat something sharp and ice and crackers and things like that, and damage can occur. But just like your cheeks, there's some really fast mitosis going on in that part of the body, and it's replenished about every 3 to 6 days. So it's really quick at keeping itself fresh and new. So if we talk about propulsion, remember we have the food coming into the from the esophagus into the stomach. It's all these hydrochloric acid and enzymes are going to be in there. You're going to have the churning, and you get this chyme, which is this liquid kind of byproduct of all that. So the final, let's see, what would you call it? The final product of all this is chyme, and we've got to push that and release it into the small intestine. And so you have this pyloric sphincter, and so at regular intervals, this pyloric sphincter will open, the stomach will contract, and just small amounts of that chyme will enter into the small intestine. So now that can go to the small intestine, and the next steps in digestion can take place. So you've got propulsion and grinding, and then what's called retropulsion, which is pushing the stuff that needs to be digested further to the top so it can keep getting grinded or ground, and then the movement of the chyme into the small intestine. So the big stuff floats to the top and gets ground some more, and the liquidy stuff gets pushed on into the small intestine, basically. All right. Some problems that can occur, gastritis, which is just inflammation of the stomach. That's typically something that has gone through the mucosal layer and caused you some inflammation of the actual muscle wall or the stomach wall. It can be ulcers, peptic or gastric ulcers. There can be erosions, which is an erosion of the gastric wall. It can be caused by many things. Used to be, people really thought it was diet, and some people thought it was certain medicines. Most people who have this gastritis, these ulcers in their stomach, is caused by H. pylori, which is a bacteria. Helicobacter pylori is kind of the #1 cause of gastritis. It can be caused by some NSAIDs. So if you have a a stomach that tends to be bothered by certain medications, they may say, well, quit taking NSAIDs and let's find you another pain medication or anti-inflammatory that doesn't bother your stomach. So that is a common problem that NSAIDs can cause ulcers. But many times you'll find that actually what you have is a bacteria that's causing your root problem of gastritis. Okay, so again, like I said with heartburn, if you kind of have, your stomach hurts all the time, it's painful, don't just assume it's nothing. Okay, there's no such thing as just a little bit of painful stomach. You want to get that checked out. Find out what's going on, because repetitive ulcers of your stomach can lead to further problems. So don't let these kind of painful issues in your esophagus and stomach go unchecked. Get it checked out and get treatment. Okay, and that's it. So our next stop will be the small intestine. See ya.